In this video we will find the product of two complex numbers which are in polar form. So first of all we have a complex number z1 which is equal to x1 plus iota y1. So the modulus of this complex number is modulus of z1 is equal to r1 which is equal to square root of x1 square plus y1 square. Then argument of z1 is equal to theta 1 which is equal to tan inverse of y1 upon x1. So this is the modulus and argument of the complex number z1. So we can express this complex number in polar form as r1 times cos of theta 1 plus iota sine theta 1. Now we will take another complex number z2 which is equal to x2 plus iota y2. So the modulus of this complex number is modulus of z2 which is equal to r2, and this is equal to square root of x2 square plus y2 square. And then argument of z2 which is the angle is equal to theta 2, and this will be equal to tangent inverse of y2 upon x2. And the complex number z2 can be expressed in polar form as r2 times cos of theta 2 plus iota sine of theta 2. Now we will find the product of these complex numbers. So the z1 z2 is equal to, we will multiply these expressions. So we have r1 times cos of theta 1 plus iota sine theta 1 multiply by r2 cos theta 2 plus iota sine theta 2, and this can be written as r1 r2 cos of theta 1 plus iota sine of theta 1 times cos of theta 2 plus iota sine of theta 2, and then r1 r2 is equal to cos of theta 1 multiplied by cos of theta 2 is cos of theta 1 cos of theta 2 plus iota sine of theta 1 multiplied by cos of theta 2 is iota sine of theta 1 cos of theta 2 plus, now cos of theta 1 times iota sine of theta 2 is iota cos of theta 1 sine of theta 2. Then we will multiply iota sine theta 1 with iota sine theta 2. So we have iota square sine theta 1 sine theta 2. Now this can be written as r1 r2 cos of theta 1 cos of theta 2. Now iota square is minus 1, so this will become minus sine of theta 1 sine of theta 2, and from these two terms we will take iota common. So we have iota times sine of theta 1 cos of theta 2 plus cos of theta 1 sine of theta 2. Now we know that this will be equal to r1 r2, and cos of theta 1 cos of theta 2 minus sine of theta 1 sine of theta 2 will be equal to cos of theta 1 plus theta 2, and then plus iota sine of theta 1 cos of theta 2 plus cos of theta 1 sine of theta 2 will be equal to sine of theta 1 plus theta 2. Now we can see that z1 z2 is equal to r1 r2 cos of theta 1 plus theta 2 plus iota sine of theta 1 plus theta 2. This is the polar form of this product. So we can see that this is the modulus of z1 z2. So the modulus of the product of complex number is r1 r2, and this is the argument or angle of the product. So argument of z1 z2 is equal to theta 1 plus theta 2. So we can say that modulus of z1 z2 is equal to r1 r2. So the value of r1 is z1 and the value of r2 is z2, modulus of z2. So the modulus of the product is equal to the product of the modulus of each complex number. And here we can see that argument of z1 and z2, the angle of the product is theta 1 plus theta 2. So theta 1 is argument of z1 plus argument of z2. So we can say that argument of the product is equal to the sum of the argument of the individual complex number. So argument of z1 z2 is equal to argument of z1 plus z2. So this is the modulus and argument of the product of the complex numbers.